Hello, I'm Jim Bellingham. I work at the Monterey Bay Aquarium Research Institute, where I develop autonomous underwater vehicles. And this is one of our vehicles that we built, which actually has been operating at this point for almost a decade in the water. Now, the systems that we build are really primarily intended for science use. So we're building systems which are intended to characterize the undersea environment, the physics of the undersea environment, the chemistry of the undersea environment, and particularly important, the biology of the undersea environment. And as a consequence, if you look at this system here, we've designed it actually to operate without people. So we're on a ship here, the Zephyr, and the Zephyr is our deployment vessel for this vehicle, which we call the Dorado. And we'll take the Dorado out a little bit later today, and this vehicle will be deployed out of Monterey Bay. And the ship will come home and leave the vehicle there. This vehicle will operate for about a day, making measurements of the undersea environment, and perhaps most uniquely, it'll be taking water samples. So this whole bay area here has a set of water samples. It takes 2 liters of sample at a gulp, and those are particularly important to us because they help us understand in greater detail what organisms are out there and perhaps to some degree what they're doing. So the parts of this vehicle that allow it to do its job start here at the front. This is the payload section. It's a very large payload section. It contains a series of different types of sensors for characterizing the temperature and the salinity of the water. So for example, we have to measure temperature to within about 1 millikelvin in order to really back out, for example, buoyancy, which is critical for a variety of reasons, for understanding the dynamics of organisms and for understanding the dynamics of the physical oceanography out there. And the temperature, having temperature very accurately, allows us to take a conductivity measurement and turn that conductivity measurement into a salinity measurement. And those are the things we need. We need to know how warm is the water, how salty is the water, and of course how deep is the water to know how heavy it is. Some of the systems that are on here that are particularly interesting is there are 2 devices actually which take photographs of the microscopic organisms that are out there, and so they give us pictures actually of the little critters that are out there growing, the phytoplankton and the zooplankton, which are really what we're interested in a lot of the experiments that we're running right now. This stern section is the part of the vehicle which really has all of the intelligence and propulsion and navigation which makes this an autonomous underwater vehicle. So this stern here has a duct and a propeller in that duct, and that duct is steerable. And by steering it, the vehicle can steer itself up or down or to either side. Up here at the top is a GPS antenna, and then along the side here there's built into the mast are actually a set of other RF antennas as well. So we actually use 2 different satellite systems, Iridium and Argos, both of which allow us to get information from the vehicle, one of which, Iridium, lets us send commands to the vehicle. And then there's a strobe. And actually, if you're recovering the vehicle at night, this strobe is visible from quite a long distance. Inside the hull, there's a set of acoustic transponders, and those acoustic transponders allow us to track the vehicle or find the vehicle if it's underwater. Now, this vehicle was actually used in the Gulf of Mexico during the Deep Horizons incident. So our operations team here in our Marine Operations Group and some of our engineers, Yan Wu Zhang and John Ryan, a scientist here, all took this vehicle down to the Gulf. And the objective there was to understand what the underwater plume structure was like from the Deep Horizon vent, from that oil gushing out on the seafloor. Where was it going? And this whole sensor payload up front was really instrumental to making those measurements, because you needed the in situ measurements to make very fine resolution measurements over a large area. But you also needed to take the water samples in order to be able to interpret those and really understand whether that oil signature you were seeing was actually from the Deep Horizon well or was oil from something else going on in the Gulf. We really want to be able to populate the ocean with increasingly sophisticated robots and ideally increasingly economical robots. So we want to make these vehicles smaller, cheaper, we want to make the sensors better, we want to make them lower power, and we want to be able to operate them for long distances and for long times and get a much better understanding of the ocean than we have today.